Good afternoon, everyone, dear authors and invited guests. Welcome to Technical Session 90. I am Meghna Mathur, and this session would be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you to the 10th International Conference on Information and Communication Technology for Competitive Strategies ICTCS 2025, Jaipur, India. The 10th edition of the conference is being organized in a hybrid mode. The physical event was held on 15th December 2025 in Jaipur, Rajasthan, and the virtual event is being held through Zoom on 16th and 17th December 2025. I hope you will enjoy the knowledgeable and interactive session throughout the day. In this session, we have 10 presentations. Each presenter will be given 10 minutes for the presentation and 2 minutes for question and answer. On 9 minutes, I will raise a gentle reminder that there is another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or any update, kindly please write me in the chat box. Just before we start our session, I would like to introduce you all with our session chair, Dr. Nitin Sakhare. Welcome, sir. Dr. Nitin Sakhare is an assistant professor in the Department of Computer Engineering at Vishwakarma Institute of Information Technology, Pune. With over 9 years of academic experience, he has published more than 30 research articles in reputed journals and authored over 100 books. His research interests include data science, machine learning, computer networking, and the Internet of Things. Welcome, sir.
Thank you, Meghna. Thank you so much.
Now we'll start with the presentations. Our first presentation is Harshvardhan Singh with the paper title A Study of Kubernetes Pod Auto Scaling in Different Load Conditions.
Hello. Hello.
Hello.
Can I share my screen for
Yes,
the presentation?
sure.
Okay. Is my screen visible?
Yes.
Okay. Wait a minute. Ma'am, is there I have to open my video or it is normal then?
Now you can proceed with your presentation.
Okay. Okay. Good morning, one and all present here. My name is Prerak Sharma. Today I'm going to present my research paper titled on a study of Kubernetes pod auto calling in different load conditionings. Okay. So, and this paper is presented in at ICTCS 2025. First of all, these are the content that I delivered today. Today, most applications run on the cloud and face changing traffics. Sometimes very few users are online, and sometimes thousands of users come at the same time. If we use manual scaling, two problems happen. Mainly two problems will happen. We use more resources than needed, which will cause money wastage, or we use fewer resources, application becomes slow or crash. So Kubernetes auto scaling solve this problem by automatically increase or decrease resources based on real time usage of for example, during event like online sales or viral content, traffic suddenly increase or auto scaling handled it automatically. Now problem is Kubernetes provide different auto scaling method, but the problem is no single method works best for every application. Some application need scaling, some need efficient resources uses, and some need both. But there is no clear answer to questions like which autoscaler should be used for what type of workload, how much money can we really save. This conclusion is the research gap that we are trying to solve. Mainly Kubernetes mainly provide the two important autoscaler, that is horizontal port autoscaler or HPA. It increase or decrease number of ports, or it was very fast as compared to other, but for web application and APIs only. And second is vertical port autoscaler, or we also say that VPA. It increase or decrease CPU and memory of a pod. It use real efficient as the following methods, and best for database and long running jobs. But in this research, we have developed a hybrid approach which use both HPA and VPA together. The main goal of our research is to compare HPA, VPA, and hybrid auto scaling. We compare them based on performance, scalability, and cost saving. The main purpose is cost saving. We tested them under different conditions like sudden traffic increases, daily repeated traffic, long-term heavy loads, and the main is batch processing job. For testing, we create a Kubernetes cluster with multiple nodes. We tested different type of applications such as web application, databases, batch jobs, and streaming services. We measured simple things like CPU and memory uses, how fast scaling happens, or response time of applications. To make experiment realistic, we test different traffic patterns. These include sudden peak like flash sales, regular daily traffic, continue high uses, and scheduled batch job, random unpredictable traffic. This helps us understand how autoscaler help in real life situations. Our result shows clear difference. HPA reacts very fast with traffic sudden increase, and VPA was slower but it was resourced more efficiently. The hybrid approach gave balanced result. So HPA gives the best speed and VPA gives better stability, and hybrid gave both speed and stability. We also check which autoscaler work best for each situation. Like for sudden traffic, we use HPA work best. And for regular and long-term load, VPA works best. And for mixed application, hybrid approach is best. So the type of application and traffic is very important when causing autoscaling. One of the most important result is cost saving. Autoscaler helped reduce cloud cost a lot. Web application saved around 55% of cost. Databases saved around 60% of cost, and batch job saved 65% of cost. So overall is 58% cost reduction, which is very significant. And the main lesson from our research are there are no single best autoscaler for all cases. HPA is used for best. I previously said it for fast just changing traffics. PPA is for stable workloads, and hybrid approach give a best balance. Proper monitoring and correct. The main thing is the proper monitoring and the correct configuration is very important for load balancing and all, and applying for the cost. These are the limitation of study limitation and the future direction like AI ML driven prediction, auto scaling, energy awareness, and sustainability. To conclude, Kubernetes autoscaling is a very important for modern cloud application. If used properly, it can improve performance, prevent crashes, save a lot of money. For always choose autoscaling based on application behavior, not guessworks or at all. So these are the reference of the research paper. So thank you for listening.
Thank you. Sir, do you have any questions for the presenter?
Yeah, just a one question. Have you used any resource allocation algorithm along with Kubernetes?
So no resource. I don't use any resource allocation algorithms, but we only that find the traffic on the at the users end and apply this traffic for the three main important Kubernetes auto scaling like HPA, BPA, and then hybrid approach.
Okay. Okay. Meghna, we can go ahead.
Okay. Moving further, we have our next author, Shivani Seni. Paper title, AI-based self-service technologies enhancing user experience and service delivery.
Yes, good afternoon, ma'am, and good afternoon to all the participants. So, thanks for giving this opportunity. I would like to, am I allowed to share the PPT?
Yes, ma'am, please share the PPT.
Yes. So, I hope this is visible. Today, I'm going to present our work on the topic AI-based self-service technologies, enhancing user experience and service delivery. Technology is revolutionizing the service delivery, we all know. And if we talk about just if we talk about the self-service technologies uh, in banks, in retail, in other at other service platforms, we all noticing that AI is helping or maybe improvising in a many ways, maybe by increasing the efficiency, by increasing the output results, or maybe the ease of use. But here in this study, we have taken the initiative to know about the user experience, because if technology and AI will be there for the consumer or for the user, and that would not fit as per the user's expectation, then we will be falling behind somewhere. So this study, this is a conceptual paper we undertaken with the two research questions. And first one, how does AI integration into SSTs enhance user experience? And second research question, how do expert systems and robot improve user experience in AI-based SSTs at service encounters? So these days, a user is a co-creator. It's not like at a receiving end only. So if the user is a co-creator, we have to learn more about their expectation. We need to understand their expectancy parameters on what level, because experience is not just functional that you got the output, it is more of multifunctional, you can say multidimensional. So to address these research questions, we gone through the literature review, and this is our first theme which we explored in the paper, that interface with the AI in the SST is a need of art. Why? Because somehow it is not just giving the customer ease to do the things. Means they are comfortable with the technology, so giving them a platform to do the things. It is more that how the AI can advance them with the, you can say, more of with the some personalized experience. They should that AI will be the more of an interface which help the user to understand or respond as per their maybe context in which they are talking, maybe to provide some inputs to improvise the input, because if somebody is using the SSTs, then they need guidance. So over there, guidance is not there, right? So user experience is that even if the guidance is there, it is more of a protocol, right? Like the steps are coming in front of you, and you have to perform on the same. Such like that chatbots or other technologies are working. So with this proposition, we are proposing that artificial intelligence based SSTs are perceived to increase the positive user experience due to advancement in the understanding, user personalization, and adaptability. So this theme have some insights, giving some insights to us that adaptive interaction and personalized interactions need to be the key of design of AI-based interface. Yes, natural language processing, facial recognition, voice, these are the advanced features, but these will not be sufficient if we'll be not able to respond to the consumers, you could say, expectation or interactions. Sometime maybe we are providing the ease of use, but more will be required, more understanding will be required to integrate the AI in the self-service technologies. Our second theme, which we have explored through the literature review, is that expert system. Although AI expert system dimension of AI, this proposition is proposing that AI is more of expert through the expert system need to be more of a context aware. Means just the solution will not serve. If customer or user is asking some specific queries in reference to the in reference to some problem, or maybe the banks are providing the 24/7 facility, and the user is expecting something personalized and some expert design help, like a human like experience. Then if there is a need of hybrid system, that need to be hybrid. But if it is through the expert system, then expert system should be should be more of like a understanding that best solution for the or proposing the best solution for the customer problems. So this was a second thing. Third theme was the role of service robots in artificial intelligence-based service technologies. Now, when we talk about user experience, we have to understand that any technology will be failed if that will not be helping to engage the customer at an emotional level. Even if we talk about some of the AI tools which we all using in our daily lives, if that will be not engaging us emotionally, means maybe through the voice, maybe through the expressions, maybe through the output, that emotional connection need to be endorsed through these technologies. So these three themes, we are proposing that these three themes are providing the framework for the AI-based self-service technologies. One is the interface, AI-based interface. Second is the expert systems. And third is the service robots. So when we talk about these three, then at a three level, we are proposing that AI interface need to be multifunctional. How the companies can go for a multifunctionality? Because they have to not to just provide the interface for efficiency, but they have to provide the interface in response to performance, engagement, ease to use, and interaction. So these are the four dimensions we proposing for integration of AI into SST. Second, when we proposing the integration of expert system, the most important is that context specific recommendations. If an expert system is backside being used, we can say maybe in the education sector or maybe in banking sector, if some problem is being proposed to the expert system to solve, and that expert system is unable to perform on that problem, then expert system should recommend the hybrid approach, and that will enhance the user experience. If it will be one-sided, just a technical answer, that might be also not very helpful to the user. Third one is the service robots. Service robots should encourage more of a human-like engagement, and that human-like engagement not to be more of a repetitive, but more of like a increasing the customer satisfaction, their positive responses. So these three themes we proposing that on these three themes we will be move ahead with the going for empirical studies. So the future research directions of this conceptual paper, first is it more of a requirement that how to use this integrated framework in the real world with the empirical validation, and more of in the healthcare, retail, banking, and other sectors. Second is the we need to understand users as well as designers' perspective, because operationalization of technology, both and need to be regulated. So this type of future studies will be required. Third is cross-cultural differences. I like to add it that somehow in Europe, in
Ma'am,
US,
sorry for the interruption. This is a gentle reminder that you have 1 to 2 minutes to conclude the presentation.
sure, thank you. 10 minutes I have, because 10 minutes have been given. Somehow I'll conclude it. This is the last one. So cross-cultural differences, Europe, Asia, or other, we have a different, you can say acceptance level. Future studies can be focused on the same. Privacy and data security measures, these can be the main aim or maybe be an agenda for the future researches. That's all from my side. Thank you so much for giving me the opportunity. Over to you, Miss Meghna.
Sir, do you have any questions for our presenter?
Yeah, ma'am, you have any approach in mind about implementation of these themes?
So in reference to research methodology means to for future applications.
Yes.
Yes, I look forward for maybe with some synthetic data first, or then I might be the real world data. First, I would like to maybe go for algorithms to understand that expert systems or the robots can be designed with those user experience based parameters or not.
Okay. Okay.
Thank you.
Yeah. Meghna, over to you.
Thank you, ma'am. We'll move further with our next presentation by author Harshita Goyal. And the paper title is Blockchain with IoT Integration, Security Issues and Challenges in Industrial Healthcare, a review.
Good. Is this visible?
Yes.
Good afternoon, respected session chairs, professors, and fellow researchers. I am Harshita Goyal from Chitkara University, Institute of Engineering and Technology. Today, I will be presenting a review paper titled Blockchain with IoT Integration in Industrial Healthcare. This work has been carried out in collaboration with Ms. Mulvigar, Dr. Anupriya, and Dr. Shirbanti Mandal, and has been accepted for presentation at ICTCS and publication in the Springer LNS series. Our paper explores how the integration of blockchain and IoT can address critical security and privacy challenges in industrial healthcare system while enabling secure, transparent, and efficient medical data management. In today's industrial healthcare environment, a vast amount of sensitive medical data is generated continuously. This data comes from hospital, diagnostics, laboratories, research centers, and increasingly from IoT-based wearable and monitoring devices. While IoT enables real-time data collection and improves patient monitoring, managing this data securely, while maintaining accessibility is still a major challenge. Most existing healthcare systems rely on centralized architectures which introduce serious limitations. These centralized systems create single point of failure and are highly vulnerable to cyber attacks, data breaches, and authentication risks. As a result, patient safety, data integrity, and trust among healthcare stakeholders can be compromised. These challenges form the core motivation behind our research. To address these challenges, our study explores the integration of blockchain technology with the Internet of Things. Blockchain introduced decentralization, immutability, and transparency, which directly address the security vulnerabilities present in the traditional healthcare system. When combined with IoT, blockchain ensures that data collected from medical devices is securely recorded, cannot be altered, and is shared only with authorized entities. This integration enables real-time monitoring, automated decision-making through smart contracts, and secure data exchange without relying on a central authority. As a result, medical data can flow securely between devices, healthcare providers, and patients while maintaining strict privacy and regulatory standards. This convergence has the potential to fundamentally transform industrial healthcare system. To understand the role of IoT in healthcare, it is important to first look at its basic architecture. IoT system in healthcare typically follow three-layer architecture while enables different data collection, transmissions, and utilization. The first layer is the perception layer. This layer consists of sensors and smart medical devices such as heartbeat monitors, glucose sensors, and wearable biosensors. These devices collect real-time uh, environmental and data directly from patients. The second layer is the network layer. This layer is responsible for securely transmitting the collected data between devices and healthcare system using encrypted communication protocols. It ensures seamless connectivity across hospitals, monitoring devices, and cloud platforms. The third layer is the application layer. This layer processes and presents the data through clinical dashboards, mobile health applications, and analytics platforms, providing actionable insights to healthcare professionals. Together, this three-tier architecture reduces human intervention, enables automated monitoring, improves operational efficiency, and supports predictive healthcare analytics. After understanding the IoT architecture, I will now explain how blockchain is integrated into medical system. In blockchain enabled healthcare, we introduce additional architectural layer to improve security, trust, and performance. The first layer is the edge computing layer. This layer processes medical data close to the source, such as near IoT sensors or gateways. By doing so, it reduces latency and bandwidth uses, which is crucial for time-critical medical applications and emergency response systems. Second layer is the blockchain layer. In this layer, smart contracts automate verification processes, ensure secure and encrypted data transfer, and maintain immutable medical records. The final layer is the application service layer. This layer supports key healthcare services such as electronic health records, remote patient monitoring, drug supply chain tracking, and AI-driven diagnostic analytics. Blockchains ensure that all these services operate on tamper-proof and trusted data. Together, this architecture enables secure, transparent, and efficient healthcare data management. Our literature survey showed that a layered security approach is the most effective way to protect blockchain-enabled IoT healthcare system. This includes network security, application security, blockchain-based access control, and AI-driven threat detection. As shown in the figure, network-level mechanisms such as firewalls, VPNs, and encryption demonstrate very high effectiveness in preventing unauthorized access. Application and cloud security tools further protect sensitive healthcare data, while physical security adds system resilience. Most importantly, AI-based and automated threat detection techniques show the highest effectiveness due to their ability to respond in real time. Overall, combining these techniques significantly improves resistance against cyber threats in industry healthcare system. The integration of blockchain with IoT offers multiple benefits for industrial healthcare system. Enhanced security is achieved through decentralization while eliminates single point of failure and prevents data tampering. Data transparency is ensured through immutable audit trails that record every interaction with medical data. Process automation is enabled by smart contracts, which automate billing, insurance claims, and secure data sharing, reduce human errors. Most importantly, this integration empowers patients by giving them direct control over who can access their health data. Together, these benefits make healthcare system more secure, efficient, and patient-centric. We propose a blockchain integrated IoT secure authentication protocol called BioSA to ensure secure communication in healthcare system. In this approach, each IoT device is registered on the blockchain and generate ECC-based public and private keys. Medical data is hashed using SHA-256, digitally signed and encrypted using AES-256 before storage. Authorized healthcare providers verify data integrity using public keys and access the data only after proper authorization. Overall, this framework ensures end-to-end security while maintaining scalability and performance for real-time healthcare applications. We compare three decentralized access control approaches using blockchain-based IoT healthcare system: role-based access control, assigns permissions based on professional roles; attribute-based encryption provides fine-grained access control based on multiple attributes, through it requires higher computational resources. Smart contract-based access control ensures transparent and tamper-proof access logging. Overall, each approach has its trade-offs, and selecting the right model depends on system requirements and available resources. Despite the advantages, integrating blockchain with IoT in healthcare presents several challenges. High operational and energy costs rise from the computational and hardware requirements of blockchain system. Scalability issues occur when heavy IoT data traffic overloads blockchain network, affecting real-time medical monitoring. Interoperability gaps exist due to legacy systems and diverse healthcare platforms. In addition, regulatory compliance, including HIPAA and GDPR, requires carefully designed legal and policy frameworks. Addressing these challenges is essential for large-scale adoption of blockchain IoT healthcare system. Future research focuses on lightweight consensus mechanisms and off-chain processing to improve scalability and reduce energy consumption. AI integration can enable predictive diagnostics, real-time threat detection, and automated analysis of healthcare data. In addition, sharding and layer 2 solutions can handle massive IoT data volumes without compromising security or real-time performance. Overall, these advancements highlights the strong potential of blockchain and IoT to create safer, more efficient, and patent-centered healthcare system. In conclusion, integrating blockchain with IoT has the potential to significantly improve security, transparency, and trust in industrial healthcare system. Although challenges such as high cost, scalability limitations, and regulatory compliances remain, ongoing research and technological advancements provide promising solutions Overall, this convergence can transform healthcare into safer, smarter, and more patient-centric ecosystem, enabling secure data sharing and improved patient care. These are the references, and thank you for your time and attention.
Thank you, Harshita. We'll move forward. Our next author is Pagaria. The paper title is CNN-based tomato leaf disease classifier.
Good afternoon, ma'am. Am I audible?
Yes.
Can I start my presentation?
Yes, please.
Yes. Ma'am, is presentation visible?
Yes.
Hello?
Yes, it is.
Yes. So, good afternoon, respected sir, ma'am, and all fellow participants. I am Karthik Pagaria from Department of AI and DS from Vishwakarma Institute of Technology, Pune. Today, I will be presenting a research paper titled CNN-based tomato leaf disease classifier, carried out under the guidance of Dr. Vyomesh Kumar Singh and along my co-authors. This work focuses on applying deep learning techniques to solve a real-world agricultural problem, early and accurate detection of tomato plant diseases. So, coming to the motivation and problem context, tomatoes are among the most widely cultivated crops globally, and they play a very vital role in agricultural economies. But however, those tomato plants are very highly prone to fungal, bacterial, and several viral diseases, which can destroy entire harvest if they are not detected at early stage. Currently, detection is mostly done through manual visual inspection, which is time consuming and prone to human error. This problem becomes more severe in rural areas, mostly in rural areas where expert agricultural support is not easily available. Hence, there is a strong need for an automated, scalable, and reliable disease detection system. So, this is our problem statement and objective. The core problem addressed in this research is automatically classify tomato leaf disease using images while minimizing dependency on expert diagnosis. Tomato diseases often show very similar visual symptoms, making manual diagnosis very difficult and error prone. Our primary objective is to design CNN-based system capable of accurately classifying tomato leaves into 10 distinct classes, means 10 distinct diseases. And secondary goal include leveraging large-scale image dataset and using pre-processing and data augmentation techniques to improve robustness of our system. And third is providing farmer a friendly interface by which he can detect the diseases. So background is traditional machine learning approaches rely heavily on handcrafted features which struggle to capture complex visual patterns under real farming conditions. CNN, on the other hand, automatically learn hierarchical feature representation directly from raw images. These studies validate CNNs as state-of-the-art solution for images-based agricultural disease classification and they motivate our approach. And literature survey includes Mohanty et al. And Zhang et al. They have demonstrated that CNN-based approaches can achieve accuracy above 95% for plant diseases detection on large dataset. In real time, our system has achieved 97.70 accuracy. Next is about dataset description, means what dataset we have used in our project. For training and evaluation, we have used dataset containing 32,500 labeled tomato leaf disease images. This dataset included 10 classes covering both healthy and major tomato leaf diseases. The images were sourced from publicly available plant disease repositories and which include real world variations such as different lighting conditions, camera angles, and background noise. Basically, we have used Kaggle and RoboFlow for dataset collection. This diversity helps in model generalization for better real field conditions. Next is system architecture. Uh, this process begins with farmer who captures or uploads the tomato leaf using a web or mobile interface. Then this image undergoes pre-processing, which includes resizing it to a standard dimension and then normalization of pixel values. Next is data augmentation technique, such as flipping, rotation, and zooming are applied, and this improves the robustness of our system by simulating real-world variations. The processed image is passed to a CNN model based on Inception V3 model, which performs feature extraction and classification. And finally, system outputs predicted disease name, confidence score, disease causes, and recommended remedy. This is end-to-end pipeline which ensures both accuracy and usability in real time. The next is CNN workflow and methodology. The CNN architecture consists of several key layers. The first one is convolutional layer with 3 by 3 or 5 by 5 filters to detect edges, textures, and disease patterns. ReLU activation, which introduces non-linearity and enables the learning of complex features. The next layer is max pooling layers to reduce spatial dimensions while preserving important information. Fourth layer is dropout layer at the rate of 0.5 to prevent overfitting of our model. And fifth is fully connected layers, following by softmax output layer for multi-class classification of the diseases. The model is trained using categorical cross entropy loss and Adam optimizer. Performance is evaluated using several metrics, which includes accuracy, then precision, recall, and F1 scores. This is our system interface and user flow. This slide means it shows implemented system interface where user can either drag and drop image and or upload image manually. Once uploaded, the model analyzes the image and displays disease name, confidence score, disease description, and recommended treatment. For example, here disease which is detected is early blight with confidence 97%. Then it includes a quick summary of that disease. Coming to the conclusion and impact, in this research demonstrate that CNN-based models can effectively automate tomato leaf disease detection. The system offers rapid diagnosis, reduced dependency on manual inspection, and early intervention to prevent future disease spread and loss to the farmer. Uh, from an from an economic perspective, early detection helps in crop losses and improve farmers' income. And from environmental perspective, it supports precision agriculture and responsible pesticide usage. So references, mainly we have referred Francois Paulet's work on CNN and Keras. Then plant detection studies by Mohanty and Zhang et al. And TensorFlow and Keras official documentation. These references ensures that our methodology follows state-of-the-art scientifically validated practices. And as of future work, we can extend this project to other crops also, not only tomato, but different types of crops also, and real-time deployment so that every farmer, every person can use this for detection of diseases and integrated of multilingual support and IoT sensors for more accurate predictions. Thank you, ma'am.
Thank you. We will move further. Our next presentation is from author Tejashri Ghadge, and the paper title is Ethical AI and Responsible AI Practices in Business.
Hello, good afternoon, everyone. Am I audible?
Yes, ma'am, you're audible.
Okay. Is my screen visible, ma'am?
Yes, it is visible.
Okay, thank you. Shall I start?
Yes, please.
Okay. So I'm Tejasri Ghadge. Today here to present a research paper presentation on ethical AI and responsible AI practices in business. My research paper ID is 511. So the authors are Pratibha Jagtap, me, Tejasri Ghadge, and Prachi Naikal. So the abstract of our research paper is artificial intelligence is becoming integral to modern business practices while AI enhances efficiency and innovation. It also raises ethical concerns related to privacy, fairness, transparency, and accountability. So this study is discuss the importance of ethical and responsible AI in the business. So this research paper studies the importance of ethical AI, responsible AI in modern business. AI is widely used in industries such as finance, healthcare, and retail to improve efficiency, accuracy, and decision making. So we are studying this. Introduction of the research paper is AI supports decision making across finance, healthcare, retail, and manufacturing. Its influence extends beyond efficiency to critical human-centered decisions. This creates a need for ethical governance to ensure trust and fairness. The objectives of our study to understand the concept of ethical and responsible AI, to analyze ethical challenges in business AI applications, to study global ethical AI frameworks, to examine industry-wise AI practices. Our ethical and responsible AI is ethical AI focuses on fairness, transparency, accountability, and human rights. Responsible AI integrates ethical values with legal and social responsibilities to ensure trustworthy AI systems. Uh, global ethical AI frameworks are European Commission ethical guidelines for trustworthy AI, OECD AI principles. These frameworks emphasizes human-centric AI fairness, transparency, and accountability. Research methodologies are used for this study. The qualitative case study approach. For study, we have chosen industries of finance, healthcare, and retail. Data sources included academic literature, policy documents, and industry reports. AI applications across the industries for finance, credit scoring, fraud detection. For these processes, AI applications are used for healthcare, diagnosis, predictive analytics, for retail, personalized recommendations, and pricing strategies. Results and discussions for the research, AI improved efficiency, accuracy, and customer engagement across sectors. However, ethical challenges such as bias, data privacy, and transparency persist and vary by industry. So the replacement of um, management is by AI uh, is not possible. Means it is not actual. Rather, go in hand with AI and management or AI and HR. Conclusion of the study is ethical AI is essential for sustainable business growth, adopting global guidelines and maintaining transparency, fairness, and accountability can help organizations build trust and long-term value. So these are our references for the study. Thank you. This is done from my side.
Thank you, ma'am. Sir, do you have any questions?
No questions.
Okay, moving further. We have our next paper authored by Risha, and the paper title is Online Attack Prevention Mechanism. We'll move further. Our next paper is being presented by Pawan Kumar Sonshi, and the paper title is Pneumonia Detection System Using LLM Model on Google Cloud Platform.
Yes, ma'am. Ma'am, I'll kindly share the PPT.
Yes, please.
Ma'am, is the screen visible, ma'am?
Yes, sir, it is visible.
Yes, ma'am. Good afternoon to one and all. Respected all the professors present here. It's my pleasure that this paper or work, whatever we have worked till now, is been accepted. We have the three authors, that is myself, Mukit Gowda, and Shantala Giredi, ma'am. I'm from Keli Technological University, Hubli, Karnataka. We have worked on pneumonia detection system using LLM model on Google Cloud platform, which is a free source to dump the projects. Coming to the contents, these are all the contents which I will be sharing, which all we have worked in the upcoming few seconds. Coming to this introduction, first of all, we need to know what is pneumonia. Pneumonia is disease where it causes the senior chest pain, and also it respiratory tracts, affects the respiratory tracts and cause the breathing problems. Early and accurate diagnosis and traditional diagnosis depends on radiologist and the sequence of doctors scanning through various procedures and all. But it requires chest X-rays and all, which requires patients for the patient to have limit in the limited of time to get the uh, treated. But using this traditional technologies, we with recent advancement in deep learnings, LLM models, automated medical images analysis have become very reliable, and they are also very effective to diagnose such kinds of disease. Cloud platforms like GCP, which we have used, that is Google Cloud Platform, make such AI solutions scalable and also help in deployment in real-time clinical settings. Coming to the problem statement, the main challenge is to build an automated and cloud-based diagnostic system that can accurately process test X-rays and also provide consistent predictions and scale efficiently without requiring deep learning expertise. This is the proposed solution. Our solution uses convolution neural networks, that is CNN based model, to extract the visual features from chest X-rays. Then we have integrated the large language model, that is LLM supported interoperability, to improve clinical understanding. The entire pipeline is automated using GCP, that is Vertex AI, from pre-processing to training and deploymenting the model to the cloud, enabling real-time and scalable inference. This is the workflow. First of all, the chest X-rays, whatever the diagnosis, are being stored in the cloud storage and is being passed to the Vertex AI. Then we have embedded the data sets, that is dataset integration. Then the model is being trained and evaluated at Vertex endpoint. Then we have the two predictions, that is normal or pneumonia, that is the output class is two, that is normal and pneumonia. Here here is a detailed explanation. First of all, the system workflow training phase. chest X-ray images are collected and uploaded to the Google Cloud storage. Vertex AI, that is Vertex AI, then structures the dataset and performed automated training using AutoML. The model learns the discriminative features and is evaluated using accuracy, precision, and recall. Based on the data sets, it learns the features and stores in the cloud's base stations. Uh, then in the inference phase, that is after validation, the trained model is deployed to the Vertex CI endpoint. Then the chest X-rays can be sent to the endpoints and the system returns predictions as normal or pneumonia with low latency, which reduces the delay. Ultimately, the latency is being reduced where it leads to the user satisfaction and the doctors get the responses or the cure for the treatment in a very short amount of time so that the patient is cured very earlier. Then this is the data set what we have used. This is just a part of it. This is a collection from a medical from Karnataka Institute of Medical Science, where we have put a lot of efforts in collecting these data sets of pneumonia. Of course, it was very difficult, but through the approach of my guide, it was possible to collect this one. Here is the explanation. It has the characteristics like normal images show clear lung fields where the pneumonia images contains opticides and dense regions indicating infections. As you can see here, some infections are been attached to the lungs. Uh, then these data set is obtained from available medical, as I told, available medical repositories from the Institute of Medical Science and ensured that clinical resiliences. Then dataset pre-processing, images are resized, normalized, and first of all, it is been cleaned, noise is been removed, and to improve the generalization and to make it more optimum, the dataset is split into the three phases, that is training, validation, and testing, and for our to ensure the unbiased evaluations. This was what about the data set, where this is the, like, we can consider as the heart of the project, because the ML models and everything training is completely depending upon the data, that is the data set. Next, this thing yeah, it needs to be deployed onto the free source, that is GCP, that is nothing but Google Cloud Platform. The trained model is deployed using Vertex AI endpoints, and then the GCP handles auto scaling, load balancing, and secure API access, enabling real-time production ready to inferences, where it learns the basic features and produces the outputs. Then uh, these are the results, that is the precision recall curve and confusion matrix. The precision recall curve shows the trade-offs between the different classification. Precision is nothing but out of all the images predicted as pneumonia, how many are actually pneumonia. Then recall shows that out of actual pneumonia cases, how many are correctly detected. This curve is especially important in medical diagnosis, where missing disease, that is false negative, becomes more dangerous than false alarm. Then coming to the confusion matrix, it compares true labels, that is actual condition, with the predicted labels. Pneumonia, true positive, false negative; normal, false positive, true negative. Then how to interpret this confusion matrix, the pneumonia and normal, that is 100% diagonally. 100% ensures that it is a true positive, that is all pneumonia images were correctly classified as pneumonia. Then 100% negative, the right diagonal to that, the blue color shown box indicates that all normal images were correctly classified as normal. Then the normal 0% false positive ensures that no normal image was incorrectly predicted as pneumonia. And then the 0% false negative indicates no pneumonia case was missed. So this was all about the precision and recall about results. Coming to the in-depth results, the model achieved the accuracy of 75%, that is 0.74 precision, and recall of 0.8, that is 80%. The average precision for pneumonia detection is 0.84, indicating strong diagnostic capability. Then the precision recall curve and confusion matrix has been illustrated to show the in-depth results what we have achieved. Then coming to the future work, what we can work further if permitted. In future work, we can plan to use the larger and balanced data sets, integrating with the higher AI technologies and models. Like now we have used the LLMs, and then we have the MLLMs, that is multi-large language models, for still more higher accuracy. And coming to the conclusion, we can conclude that we developed an automated and scalable pneumonia detection system using the convolution neural networks, that is CNN model, and the GCP, that is Google Cloud Platform, Vertex AI. Cloud native pipeline enables efficient deployment and reliable real-time diagnostic, making it suitable for practical healthcare applications. This was all our work. Thank you.
Thank you, sir.
Thank you,
Our
ma'am.
next presentation is from author Keshavar, and the paper title is Review on the Defect Detection on Silk Sari Using AI. We'll move further. Our next author is M. Hosana, and the paper title is Text Classification Methods for Cyberbullying Detection on Social Media Platform.
Good afternoon, ma'am. Am I audible?
Yes, ma'am, you're audible.
Good afternoon to everyone. I'm going to present my research paper, Test Classification Methods for Cyberbullying Detection on Social Media Platform. Myself, Posna, scholar, Department of Computer Science, Sri Meenakshi Government Arts College for Women, Madurai. This research focus on using advanced artificial intelligence method to detect cyberbullying on social media. Cyberbullying is a critical threat to mental health, but current detection systems struggle with speed and computational cost. The study
Ma'am,
compares.
sorry to interrupt. Your PPT
Yes,
is
ma'am.
not visible.
Oh, sorry, ma'am. Is visible? Ma'am?
It is visible, ma'am. Please
Yes.
go ahead.
Okay. Shall I start in the beginning?
No, ma'am, you may continue. It's visible now.
Okay, ma'am. Okay, ma'am. Thank you, ma'am. Cyberbullying is a critical threat to mental health, but current detection systems struggle with the speed and computational cost. The study compares different large language models to find the most efficient solution. Cyberbullying highly affect youth and teenagers. They're facing the issues like depression. Traditional manual monitoring is too slow. We need automated machine learning tools to monitor social media in real time. For research, we reviewed the recent studies from 2021 to 24. While various model shows high accuracy, they often suffer from beginning expensive or limited to specific language. There is a clear need for models that are both high accuracy and lightweight for large scale use. These are the research gaps that I found in various models. This is my workflow that we move from data collection and pre-processing model, training and final evaluation. The raw social media text is cleaned, processed through a transform-based model, and then classified as bullying or non-bullying words. This is the explanation of my workflow. In this project, I used this models for comparison. Each model produced the matrix like accuracy, precision, recall, F1 score, and error rate. This is the result that each model produced for each matrix. The final conclusion, BRT algorithm achieved high performance to find bullying text in social media performance. These are the paper I reference for this, my paper. Thank you, ma'am. Thank you, sir.
Thank you, ma'am. We'll move further. Our next presentation is from the author Abhishek, and the paper title is UNet for Pixel-Wise Change Detection in Hyperspectral Remote Sensing Images.
Good afternoon, ma'am. Good afternoon, everyone who all are gathered here. Thank you for giving me this opportunity. Ma'am, is my presentation visible?
Yes, your presentation is visible.
Okay. Good afternoon, ma'am. My name is N. Abhishek. I am from Keli Technological University from Hubballi, Karnataka. So today I am presenting on the paper unit for pixel-wise change detection in hyperspectral remote sensing images. So we have thought to work on hyperspectral images, that is satellite images, for change detection in the lands. So this is the introduction here. So we can see the changes in the land due to some many reasons like urbanization or agriculture or even deforestation or in any other natural disasters. So to one second now. So to check the change detection in the land covers, so there are few detection methods and they fail to capture complex spatial patterns in high dimensional hyperspectral data. So why hyperspectral images? If we see that, so the hyperspectral data will have many bands, many spectral bands, and each pixel contains a full reflectance spectrum, so we can easily find out the detection in the land changes. And hyperspectral images can provide rich spectral information, and it enables the precise identification of subtle land cover changes. So even here we are using deep learning methods, like, so we have used all very well known architecture, UNet architecture. It's well suited here due to its encoder decoder design, where encoder will extract the features and decoder is used for upsampling the size, and it even has these skip connections, and this architecture enables precise and scalable change mapping. So this is all about the introduction of what we have been worked on for this research. So this is our problem statement. We have thought to design and develop a system that performs accurate change detection on hyperspectral imagery, enabling effective monitoring and classification of land cover changes over time. So what were our objectives of our work are like we to pre-process the hyperspectral data for better model accuracy, to perform change detection on hyperspectral imagery to identify land cover changes over time, and to use segmentation to improve feature extraction and change detection in hyperspectral data. So these were our objectives of our work. So for our work, we have used two data sets. Like one is Armiston data set and another one is wetland data set. So here are like sample data images. One is from Armiston and another from wetland data set. And we have used ground truth for checking for evaluation purpose. We have even used the ground truth also. So this is the data set description. We can see here like the Hermiston dataset, like it's in a .mat format, and in pre-processing we will convert it, and we will normalize it also. We will take here we have a Hermiston dataset like of 2004 and 2007, like two timelines. I will explain it in further. And we have ground truths as I earlier have said. And in wetland area dataset we have 2006 dataset and 2007, and it has 128 selected bands were retained from the original 242 after pre-processing. So this is the model architecture of our work. So in this we can see that the data input has like T1 image and T2 image. T1 and T2 are like timeline 1 and timeline 2. We are checking the detection in land cover changes between the timeline 1 and timeline 2. Like we have seen that Armiston dataset is like 2006 and 2007, like that. So timeline 1 and timeline 2. Then we will further proceed to pre-processing part, where we will do the normalization and concatenation. Why we have to do the concatenation? In the sense like to learn temporal differences between the pixels or in images, we have to do the concatenation between the images. And from there, pre-processing, we will go for the patch extraction. From there, patch extraction, we will go to the model, deep learning model, where unit generator, encoder and decoder. So encoder and decoder, we know that like in encoder, it's a contracting path where it extracts high level spatial features, and in decoder it's expanding path, like it will recover the spatial resolution, performing precise localization. Like in between this there is a latent space where the features are being extracted and the model will learn about the features. So this is all about the unit model. From there we will go for inference and visualization, where there will be the prediction, RGB decoding and RGB view. And there the final output of our model will be the like change detection map. We will get them like map, change detection map. So what I have already said, I have mentioned the points like input data, pre-processing part, and the patch extraction part, and data set formation and unit, and inference stage, visualization, and the final output as a change detection map. So there are like 8 classes changes. Visually highlights 8 class changes across the 2 timelines. So these are like a few sample outputs or sample results, where we have got like there is a ground truth and we have predicted mask from our model, what we have been trained and tested. So this is a few results of our work, and that is image results. And when we quantized it, or when we gave like accuracy, we have checked the accuracy, precision, recall, and F1 score, and even IOU score. So these are like all the classes from the 8 classes, or 7 classes in wetland and 8 classes in Hermiston dataset. So we have got different values for different classes, and overall accuracy for wetland area dataset we have got 0.87, and for overall accuracy in Hermiston dataset is like 0.84. So even IOU score, mean IOU score of wetland dataset is 0.5969, and for Hermiston dataset is 0.6001. So these are the results we have got from our work. And coming to the conclusion and future work of the our work, conclusion is like that. UNet, we have used UNet because it effectively performs the pixel wise extraction and pixel wise change detection by learning the spatial and spectral features from hyperspectral image pairs. And it has a strong performance on benchmark datasets, like as we have done on wetland and Armiston, and it demonstrates the model's reliability and scalability for real world environment monitoring. So earlier I have said like encoder decoder architecture with skip connections enables accurate segmentation of logs and continuous change regions. So performance in few part, like performance can be affected by class imbalance. There will be imbalance between the classes, and with minority change classes showing like lower IOU score and F1 scores. So it is a major like highlighting a key limitation. So when we go for like what are the feature works can be done with this current work, like feature works can be including like integrating attention mechanisms, self attention, cross attention mechanisms, like they will focus on the relevant data in the data set. So we can integrate those attention mechanisms, and we can advance the data augmentations where flipping and all will be done with the data set. And even multimodal data like HSI, LIDAR, and SAR, we can use those data to improve robustness and minority class detection. So these are all the this is all about our work and the paper. So thank you for giving me opportunity. Thank you one and all.
So, do you have any questions for our presenter?
No questions.
Moving further. Thank you, everyone. I sincerely thank all our authors for their excellent presentation and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for the support during this 10th version and all the previous 9 versions. Hope this session was informative enough for everyone. We, on behalf of the whole team, thank you for the support during this 10th version and all the previous 9 versions of the conference. We will be happy to have you back in the 11th version in 2026. All the presenters would be getting their digital certificates through email within 2 working days. The publication will be live within 7 to 8 months. Kindly cooperate with the team of ICTCS 2025. I also thank our session chair, Dr. Nitin Sakhare. Thank you, sir. Would you like to address the authors? I would like all the participants remaining to kindly please turn on the camera for a snapshot. Rishabh, are you there to present your paper?
Yes, ma'am. Can I present now?
Sure,
Hello.
please. Yeah, please do the presentation. Yeah, Rishabh, you can present your paper.
Yes, ma'am, I'm sharing the screen now. Is my presentation visible, ma'am? Hello?
No, it is not visible.
Uh, is it visible now, ma'am?
Yes, it is visible. Kindly
Okay.
proceed.
Hello to one and all. I'm giving a presentation on online attack prevention mechanism. So basically, abstract of the presentation is mainly in the bank areas. What is happening that a lot of online attacks using the malicious links and also the malware detection, cyber security attack. A lot of things are happening. So like loan prediction analysis, what basically I'm doing here, which is a critical component of financial sector, focusing on evaluating borrowers' credit worthiness. So this project basically aims to develop a robust predictive model that assesses loan approval, helping institutions make informed lending decisions. Technology which I have used here is the pattern matching, which I will explain further. So these systems basically enable a timely intervention by alerting the analyst for suspicious activities that mirror past frauds. And data analysis also plays a major role. So methodology first is the anomaly detection in fraud detection. So what it basically does that seeing the irregularities on the credit card, it will detect that whether it is a genuine credit card or a fake credit card as per the anomaly detection. Also, when it comes down to URL detection, it uses couple of more technologies, including the correlation analysis, data visualization, and segmentation analysis for checking whether the link is a malicious link or a genuine link. So technology used over here is cyber security awareness, where the risk assessment is basically the skills in identifying and assessing the potential security vulnerabilities related to the fraud, and the incident response, that is understanding of protocols for responding to and mitigating fraudulent activities. In the software development, it is using API development, version control, and programming skills. Now talking about the implementation, basically is in two stages. One is building and training the models to detect whether the credit card is a genuine one or not, and also if the malicious link is a genuine link or a malicious one. And finally comes the testing and validation to check following way it is done doing the testing. As you can see that the legitimate versus fraudulent transactions in a data set. So one is for the legit one and zero is for the fraud one. So these many are the legit database, that is the links are a safe one, and these are the malicious links, and similar set can be seen when these technologies are used, that is the data collection, data processing, and the model selection. Following the conclusion, I would like to conclude that this model analyzes key features such as credit history, income, and loan amount. This model also helps in minimizing risks associated with the loan defaults. Solution can be further developed into real-time applications to enhance the efficiency of loan approval process, and continuous monitoring, regular updates for detection models, and the integration of the emerging technologies such as artificial intelligence and ML will be a crucial stage. Future scope is that how the technology can transform the traditional lending practices into more efficient one, data driven, and ultimately leading to better decision making. These are some of the references which I have added. Thank you.
Thank you, Rishabh.
Yes, ma'am.
All the participants kindly please turn on the camera for the snapshot. Thank you, everyone.